All right, so welcome everyone. I'm just gonna go through these notes in case you're not in class, or if you want to check out this video, it might help you out with this section. But basically, we're gonna be looking at distributed and foiling today. Basically, this is how we can go from something in factored form back to standard form. Basically, it's the opposite of what we did last week or before spring break with factoring. Just some vocabulary just to make sure some words I'm using don't throw you off too much. But just remember an equation. When we talk about an equation, that's just like a mathematical expression or like a sentence in math that has an equal sign in it. A quadratic equation is an equation with an x squared in it. A binomial is an expression with two parts. For like example, x plus 2 or x minus 5 are binomials because you have like two pieces there. You have like the x part and the constant part. So if you have like two things separated by a plus or minus, that's a fancy word for that's a binomial. So if you see binomial, it just means you have two things like together. But like I said, our goal is to go from factored form. If you remember, like factored form from before break was like we would do the x method and we would get like x plus 2, x minus 5, for example. And we're going to try and turn that back. So first thing we're just going to practice is distributive property. Just because like this would be doing the opposite of a GCF, for example, our last section before we went on break. But just remember when you distribute, you just multiply everything in the parentheses by your outside number. So like 9 times W would be 9W. 9 times 3x would be 27x. Similar idea with this one. If you're multiplying it out, 6 times 3y is 18y. 6 times 6 would be 36. So when you distribute our multiplies, we're going to get some kind of expression is our final result. So that shouldn't be too bad, but we're going to see if there's going to be two ways we're going to multiply these binomials together. One is the box method and one is the FOIL method. If you choose the FOIL method, basically you have to distribute twice. So I just want to make sure we can distribute before we get there. So like I said, there's two ways to multiply binomials. The most common I usually find students use is the box method, but some of you will prefer the FOIL method, or maybe that's what you saw maybe back in Algebra 1, depending on your teacher. But the box method, you put one of your binomials along the top, and you put one of your binomials along the side. It doesn't matter which one you put along the top and the bottom. I usually put the first one on the top, the second one on the side, though. So to do the box method, we're going to kind of multiply where kind of our things meet. So for example, 3x times negative 4x is what's going to go in that top left box. So you just multiply negative 4 times 3 is negative 12. If you ever have two x's, remember x times x is x squared. So we're going to have an x squared in the top box because we have an x here and an x here. Our next thing we're going to multiply is where these meet. So negative 4x times positive 2 would be negative 8x. And then we're going to multiply where these meet. So negative 5 times 3x would be negative 15x. And then lastly, negative 5 times 2 would be negative 10. Once you've got your box like filled in, you're going to add everything together. So you only have one part with an x squared, so that just comes out. But you can, if we're doing like binomials like these, you're going to see this diagonal here is always going to be your like term. So we can combine those together. I usually just do this before I write it down. So what's negative 15x plus negative 8x? Use a calculator if you need to, but it would be minus or negative 23x. And then the minus 10 just comes along. But basically, you want to combine any like terms from your box, and usually it's going to be that diagonal. You're going to see our like terms for these. Pretty much any problem we're looking at, that's going to be true. Okay, so that's the first method. If you like the box method, I mean, you could do that for all these problems. You'll see in the delta math, you kind of have a choice for the last bit of it. But I do want to show you how to FOIL, just in case it's something maybe you've seen before, or if you prefer it over the box method. Some people don't like drawing the boxes. It's up to you. But if you do the FOIL method, basically what you do is you take the first part and you distribute it. So we just kind of ignore that plus 5 for now. So like 3x times 2x, well, that would be 6x squared. because 3 times 2 is 6. X times x is x squared. So if you have 2 x's, you have a power of 2. And then 3x times 9 would be 27x. 3 times 9 is 27, and then you just bring the x along. So then now we're going to deal with this plus 5 part. So now we're going to distribute the plus 5. So we're going to get plus 10x. 5 times 2x, 5 times 2 is 10, bring the x with it. And then 5 times 9 would be plus 45. And then from here, we just want to combine like terms. And it's similar to the box method. It's this x part. I mean, for pretty much what we're looking at with quadratics, it's going to be these middle 2 terms or pieces we can combine. So the 6x squared just comes down. 27 plus 10, that would be 37 regular x's. And then the 45, the constant, comes down. So you could also, but like I said, I mean, if you prefer, you also could do the box method. Like you could just draw a box. You could put the first one, like I said, I usually put on the top, the second one on the side. If you work it out, you'll get the same result. So I just want to show you there's 2 options. To be honest with you, if you're like in a college class, they're probably going to show you the FOIL method, I would assume. But the box method is definitely a valid method. It helps kind of organize your information. So we'll see how this goes. So, but basically what we're doing is this is the opposite of factoring. This is like, maybe I should have actually started with this, but factoring basically does the reverse. So if you wanted to go from factored form to standard form, you can do what we're doing today. If you want to go from standard, like an answer, like for example, if we wanted to take an answer like this, we could factor it. This one would actually be a little bit harder because our A isn't 1, but we'll kind of learn new tricks for that later in this unit. But hopefully this helps some people, but we'll be working on this starting this week. We'll see kind of how it goes.